Hello, NG Japan. How are you doing today? Oh, I think people are still kind of in lunch mode. Or... Right, so I realize my talk is right after lunch, so maybe some of you are planning to doze off, or no? Okay, we've got a captive audience here. Cool. So, my name is ANAND GUPTA. I'm based in Singapore, and I work for a investment and wealth management bank here as a full stack developer and technical lead. Welcome to my talk, Micro Front-End Architecture with Framework Agnostic Web Components. Has anyone heard of Micro Front-End earlier? Show of hands. Okay, some of you. Good. Web components. Of course, there's Angular components. Awesome. Great. So let's start with the definition of what micro front-end is. So there are a number of definitions that float around, and I guess all of them are correct. But the one that I found closest to what I understand is something that I found on Martin Fowler's site, an architectural style where independently deliverable front-end applications are composed into a greater whole. Now there are a few characteristics in a micro front-end architecture that kind of stand out. So some of them are small and focused. So in a micro front-end architecture, you would see the teams are small and focused into a specific business domain or a business requirement. We have autonomous teams who are basically responsible for the entire development pipeline, right from the writing the code or testing, building, deploying and releasing as well. And the best part is that they have the freedom to choose the technology stack that they want. So they don't have to, they can use the tools that they like, that they're familiar with, or the right tool for the right job. Micro frontend is also known by different terminologies, so you would see usage of these terms like micro apps, composite UI, front-end microservices. That's also a term that I've heard, but they all kind of essentially mean the same thing. So if you have heard any of those terms, they basically mean micro frontend. Right. So let's understand what micro frontend architecture is. To understand this, we'll probably go back a little bit and see how the web architecture has evolved over the period of time. So back then, we used to have this monolith where both the front end and the back end are basically the same code base. So if people have done development in ASP.NET, GSP, anybody? ASP.NET? Okay, clear, good. So back then we would have the same code base, which is basically doing the both back end and the front end together. And that worked fine, and that still works fine for small to medium applications. But when it starts growing big, you kind of start thinking about how to separate the front end and the back end. And that led to this architecture, where we have a dedicated team for front end and a dedicated team for back end. So we have a separation of concerns here. And this is also the time when we had, when we saw the emergence of SPA applications, like Angular, React. And this has been working pretty well for even now. I mean, I guess this is probably one of the more popular ones. But then something happened. Microservices. I think this is probably the buzzword that everybody talks about. So basically what microservices architecture essentially means is that you basically divide your backend further around business capabilities or business use cases. If anybody has heard the term bounded context, in the domain-driven design, has anyone heard of bounded context? Okay. So basically, you divide your teams around the business capability or a business use case, and those are small and focused teams and responsible for building and deploying independently. Basically, so each team basically would be independent in their workflow, and this had several benefits. So small and focused. We had autonomous teams doing, having independent development and the release schedule. Technology choice, people could write one backend in Java and the other in Go and the other in C Sharp or whatever. And this is where we currently are. I think this architecture has been quite popularized with the likes of Netflix. Um, so there was just one little thing I feel hasn't quite realized with this approach yet, which is the independent release. So while it's true that each of the team can release their backend feature independently, but they're still kind of constrained by what the front-end team is doing. So even though they might have introduced a new endpoint, but it still can't be used until the front-end team kind of agrees to or has time to start using that. So front-end is now the new monolith. So it is now the new bottleneck. So we still cannot release a feature independently. So that is where micro front-end comes in, and it says, okay, whatever we did for the backend, we're going to do the same thing in the front end. So we're going to split the UI as well into different small apps, and each team would be responsible to also deliver the front end. So each team now is not just doing the back end, also doing the front end for that specific business use case. Now the teams are basically, so what we have done is we have extended the benefits that we had in the backend microservices. We extended that to the front end. So now we have the same benefits available to us on the front end as well. So now we have a truly independent release for every feature for that specific business case. So that's how micro front end came in the picture. Right. So now that we know what it is, how do we implement it? Right. There are a few approaches, and there are some of them are quite simple to implement actually, and we kind of already use them. I guess the simplest one is using hyperlinks. I'm sure everybody knows what hyperlinks are, and we kind of use it every day. If you've used Google, or if you used Microsoft Office online, I guess you already have used that. So it's a pretty simple way of having different applications hosted, independently, but we kind of link all of them together using maybe a menu or on a page. And when you click on each of them, it basically opens that application. But the disadvantage is that it's a hard navigation because there's a full page reload that happens, right? And that's not a great experience. But it's pretty easy to implement, right? The next approach is using iframes. Has anybody used iframes here? Okay, so I guess that says it all. Okay, so I guess iframes earned this reputation of as a nasty reputation of having security issues with it, which is why people kind of try to avoid it, but it kind of gets the work done. I guess I believe iframe in the context of micro frontend would be okay to use if you are aware of those security considerations and if you have legacy apps that you want to support as part of the micro frontend. The problems are that it would be the whole routing and deep linking. I think that would be a bit of a challenge to implement there. And also the shared state. I mean, there won't be much of a shared state between the different micro apps. So this leads me to the next approach, which is the web components, and this is also the second part of my talk that I'm going to focus on, which is web components, and it's basically a web standard specification. It's a reusable framework, agnostic way of building components. It's actually not just a single spec. There's no spec for web components. It's basically a suite of smaller technologies, web technologies, the specs for those that make up the web component. So you deliver a web component by implementing a number of different web specifications. So what are those? So we have HTML. So these are the specifications that make up the web components: HTML imports, HTML templates, custom elements, and shadow DOM. We'll briefly just understand what these are. HTML imports is basically a way of importing one HTML document into another HTML document. But the browsers did not agree on its adoption or its implementation. So now it's basically deprecated. We're not going to talk about it. Yeah. But we are going to focus on the other three specs. So the next one is HTML templates. HTML templates is basically defined using the template tag. I think everybody here probably already knows. We're at an Angular conference. We have all used templates, right? So that's basically what HTML template means. It's a template tag which encapsulates a bunch of markup, but that doesn't get rendered by the browser. So the only purpose defining that is to be able to load and to load it at runtime dynamically by JavaScript, right? So that's what HTML templates are. Custom elements is probably the heart of the application, the heart of the web components, and I'm going to focus a little more on this in the upcoming slides. So it's a way of creating your HTML, new HTML elements. So you must already be, we already used to using HTML elements like import, a button, a select. So how do we create a new HTML element of our own? So that's what custom element is all about. And the shadow DOM basically allows us to encapsulate the style and the DOM of the custom element defined under something called shadow root from the rest of the DOM, which a lot of people like to call as a light DOM. So there's a light DOM and there's a shadow DOM, and it ring fences the two. So the style that we have defined inside the custom element doesn't get leaked out to the global or outside of it. And if we have defined some style outside of custom element as a global style, that does not interfere with the styling of the custom. So that allows us to deliver feature-rich web component in the way and render it the way we actually intended, right? So that's what shadow DOM is. Right. So let's dig a bit deeper what custom elements are. This is the most basic implementation of custom elements. All that we need to do is declare a ES6 class. It has to be an ES6 class that extends HTML element. Okay, HTML element is an inbuilt type. So we just extend that. There are a number of hooks, as you can see. There's this connected callback that gets called when the custom element gets added to the DOM. There's a disconnected callback that gets called when the custom element gets removed from the DOM. The attribute change callback gets called when any of the attributes of the custom element changes. And the observed attributes property is basically the list of the attributes of the custom element that we want to observe, and only for those properties the attribute change callback is going to be called. Once we have declared this, we need to define this or register this custom element with the document, and we do that using custom elements.define. So that's an inbuilt globally available property here. So custom elements are defined, and we pass on the name of the custom element, and then we pass on the class name, the class type, right? There's one other requirement to define the custom element, which is the name has to have a single dash, at least a single dash. It could be more than one, but it definitely needs to have at least a single dash in its name. That's a hard requirement. So the two requirements to summarize are that it needs to have it has to be an ES6 class extending HTML element, and it needs to have a name that has at least a dash. So once we have defined that in a JS file, all that we need to do to be able to use it is use a script tag, and then we are just free to use the custom element exactly the way that we use a button tag or an input tag. Yeah. It's pretty simple. Right. So how are we doing in terms of framework support? So all the major web frameworks are supporting custom elements. I think we are already familiar with Angular elements here. We have a talk after my talk by Jia. So he is going to speak on Angular elements. So he's going to go deep dive into that. And I understand he's also going to share show you some code as well. With React, there's a community project called Web React Components, or you can also wrap it by yourself. It's pretty simple to do. I've done that in the demo application that I'm going to show you. With Vue, there's a Vue CLI command that you can do that you can use to wrap a Vue application as a web component. And with Aurelia, there's a project called Aurelia Web Components. It's very similar to the Angular elements. And there's this website that kind of tracks the level of support. And as you can see, Angular and Vue are basically 100%. They score 100%, and React is at 71%. It basically passes all the basic tests. It's just a few of the advanced test cases that it doesn't pass as yet. Right, cool. So demo time. So this is an Angular application. However, as you can see on the left navigation, you can see that we have these different modules. So you can imagine these as like separate teams that kind of develop these different modules. So you have the discover, product, payment, account, the orders. So, but each of these have actually been written in a different framework, but wrapped as a web component. So this is the application that I've written in Angular and then wrapped it as a web component with the Angular elements. And it's got its own router. So the router also works here. This component is written in React and wrapped as a web component. It also has its own router that you can use to route between pages. This is an application written in Vue. And this is an application that has been written in Aurelia. And you also see using Vanilla.js and a web component. And all of them are kind of playing together in the same Angular application. So this allows each of the team to use whatever framework of the choice they have without having everybody to use the exact same framework or even the same version. Right. So I just wanted to show you how web component can act as a unifying common denominator. Right. So browser support. As you can see, almost all the browsers are supporting all of the specification of web components. The only outlier here is Edge, which is indicated that it's going to support custom elements and Charo, but since then we have also seen the news that Edge is now going to be based on Chromium, so in a way it's easy to support all of this specification. For those cases that where you want to support an older browser like i11 or even Edge today, so there's a polyfill that you can use so that you can use web components today, even on those old browsers. And even if you use the, say, the evergreen browsers that support web components, but for some reason you've decided that it needs to be compiled to ES5, you will land up with an issue there, but there's a polyfill for that as well. So if you use ES5 on Chrome and you want to use web components, then there's a polyfill that you can use for that. Now, this micro front-end architecture, while it has several benefits as we have discussed, it's not without a few issues that we need to consider. It's not a silver bullet. So there are issues, not issues, but kind of it's a bit more work to ensure that there is, if you want to have a communication between the different micro front-ends. Very similar to the issues that we have encountered and solved on the back end of the microservices. UI consistency could be an issue if because each team is developing its own front end. So we need to ensure that the UI experience is identical. So there are people that gone with the approach of standardize with that. The bundle size could be more because there are shared libraries and each team is developing its own application, so there could be some shared libraries that we are bundling multiple times. Leads to the same issues with duplicate code, and also as a consequence of that, performance could take a hit as well because the bundle sizes could be large. However, there are ways and means to kind of mitigate some of these issues with the code splitting and Angular ID coming in. So yeah, if you're developing an Angular, then the framework size, the runtime size will be small. Yeah, so there are ways to mitigate. You can also use lazy loading, for example, but we need to be aware of these issues. So that's the summary of what we discussed today. So we understood what micro front-end architecture is. We briefly discussed what web components are, what custom elements are, and we also saw how different frameworks can be unified under a single application using web components. And we also try to go through the issues that we need to be aware of. So here's my code. If you want to play around, it's the same code that I showed for the demo. And you can find my slides here. You can follow me on Twitter. I'm also on Medium. I've written some blogs on this topic, so if you want to catch up on those, this is my Twitter site. Thank you. Arigato gozaimasu.